something like this. So we have talked so far this unit about how our solutions are where it crosses the x-axis. As we can see, this graph doesn't touch the x-axis. So based off what we already know, that should be no solution. But the thing is, because this is x squared, we know that something has to make up that x squared, and that would be x times x, right? So that means there needs to be at least two values of x that makes this true. So if I was to try to solve this, I'd subtract 1 on both sides, get x squared equals -1, take the square root of both sides, get x is equal to, well, we've been told basically for all of our math classes we can't take the square root of -1. But the real answer to that is we can't take it with a real number. The number we use to do that is I, and it would still be positive or negative right there. But so one thing that I want us to make sure we know is that imaginary number is I is equal to the square root of -1. Now for equations such as x squared plus 1 equals 0, they don't have a real solution, but they do have a solution. It's still made up of something. So mathematicians define the imaginary numbers to represent those solutions that it's made up of. And the imaginary unit is I, and it is defined as I is equal to the square root of -1. So a pure imaginary number is written in the form of bi, where b is the real number and I is the imaginary number. So the reason it can be written like that is so we can write things like 2i, -7i, 5i. That was a bad I. Okay, all of those are examples of imaginary numbers. Now we're going to rewrite and simplify negative square roots using this same idea. So in order to do that, we have to first break it into the imaginary part and the real part. So basically we pull out that square root of -1 because we know the square root of -1 is I, and then we can deal with whatever's left. So the square root of 9 is 3. So that means we'll get 3i. For number 14, we're going to split it into the square root of -1 times the square root of 196. So we get I times 14, or 14i. For number 15, we split it. So square root of -1 times the square root of 5. Square root of -1 is I. We cannot take the square root of 5, and there's not a perfect square that goes into it, so it is just going to stay times the square root of 5. Now, we do leave this written this way because if I wrote the square root of 5i, it kind of looks like the I is included under the radical. We don't want that, okay? We want to make sure it's very distinctly outside, so that's why we put it in front. Now we're going to look at the back page, do a few more of these. So as we look at a few more of these, we're going to do the square root of -80. So first, split that into the square root of -1 times the square root of 80. Now, we can break up the square root of 80 even further than that because we can't take the square root of 80. We can do the square root of 16 times the square root of 5. We're still dealing with the square root of -1, which is I. So we're going to have I times 4 times root 5, or 4i root 5. Now we're going to do the same thing for 17. So we have the square root of -1 times the square root of 32, which we can break that down even further. We can break that into the square root of 16 times the square root of 2. So we get I times 4 times root 2, or 4i root 2. For the square root of -192, we can break that into the square root of -1 times the square root of 192. But we can break that down even further. We can break that down to 64 times the square root of 3, which gives us 8i root 3. Now for number 19, that is just 8i. Number 20 is 2i, because the square root of 4 is 2. The square root of -1 is I. This one here, we can break that into the square root of -1 times the square root of 9 times the square root of 13. So we get 3i root 13. Now, we can also have a combination of real and imaginary numbers. So when we have that, it is called a complex number, and it is always written in the form of a plus bi. So when it is written in the form of a plus bi, the real part, or a, comes first. Then the imaginary part, bi, comes second. So we would write it as 2 minus 3i, or we could say 5 plus 6i, 3 plus 2i, whatever you want. As long as it's a real part and imaginary part, that makes it a complex number. So we're going to go through some operations with complex numbers. So before we do that though, if I have I is equal to the square root of -1, if I wanted to get rid of that square root, I would do that by squaring both sides. So if we do that, we get I squared. Then when we take the square root of a square, or square a square root, they essentially undo each other. And it leaves just what's underneath the radical. So in this case, -1. So we have that I squared is -1. So whenever we're dealing with operations with complex numbers, we can sometimes simplify the imaginary number completely out using that property. So let's look at 22. So if we look at 22, we have 4I times 7I. 4 times 7 is 28. I times I is I squared. So we actually get 28 times -1, which is -28. So that's our answer. So we completely eliminate the I. For this one, when you square a monomial, it is the same thing as that square going to both pieces. So we're saying I squared and the square root of 3 squared. Now I squared is -1. The square root of 3 squared, again, it cancels out the square in the radical, leaves us with just what's underneath, so that will be 3. So we have -3 right there. Now we're going to multiply that, and we're going to do the other side. Same thing, we would square in a monomial, so everything gets squared. -8 squared and I squared. So we get 64 times -1, or -64. We multiply those together, and we get positive 192. Again, our imaginary number goes completely away, and we end up with a real number. For number 24, we can break down these radicals just like we did the earlier ones. We can rewrite this first one as the square root of -1 times the square root of 9 times the square root of 2, which gives us 3I root 2. Then we can rewrite the square root of -10 as the square root of -1 times the square root of 10, because we can't break that down any further, and it gives us I root 10. So we get 3I squared times the square root of 20, which this can be broken down even further, and we can replace this. So we get 3 times -1. We can break this down into the square root of 4 times the square root of 5, which gives us 2 root 5. Multiply all this together, we get -6 root 5 is our answer. This one, very, very similar. We break down the square root of -24 to get 2I root 6. Break down that to get 3I root 3. Multiply them together, get 2I squared times the square root of 18. We get 2 times -1 times 3 root 2. So we get -6 root 2. So with all of those, because we're squaring I, we're ending up getting -1, so we can completely eliminate our imaginary number. Now we're going to look at combining like terms. So if we look at number 26, we start with just adding. So this here doesn't change, so we bring it down. Then positive and a positive is still positive. Then we combine like terms, and we're going to write it in the correct complex number form. So real part first. So our real like terms is -11 and 9, which gives us -2. And then our imaginary like terms is 3I plus 2I, which is 5I. So here, because we're just adding and subtracting, we don't get rid of our I because it does not become I squared. For 27, same thing, we have 4 plus I. Positive and a positive is positive. Positive and a negative is negative. We get real part, which is 11. Imaginary part gives us -4I. Now, we actually didn't get to these in class, but I am going to go over a few of them just because we're not really going to have a lot of time to do them in the future. So if we look here, we're going to have 7 minus 2I, but here a negative and a positive is going to make that negative. Negative and a positive is going to make it negative. Real part. Imaginary part. So we get 5 minus 8I. So here, same thing. 6, then we're going to minus 14 plus I plus 5 minus 3I. So we're going to have our real part first. So it gives us -3. Then we're going to our imaginary part, which is going to give us negative 2i. Now here we're just distributing, so 2i times 8 gives us 16i. 2i times negative 3i is going to give us negative 6i squared, which 16i minus 6 times negative 1, we get 16i plus 6, which that's not written in the correct form. We'll write 6 plus 16i. And you would do the same thing for 31, and your resulting answer for 31 is going to be 10 minus 2i. Number 32, we're still just distributing. 7 times 4 gives us 28. 7 times negative 1 is negative 7i. I times 4 is 4i. I times negative I is negative I squared. And so we're going to combine some like terms. We get 28 minus, that is 3i minus I squared, which is just negative 1. So combine our real part and our imaginary part. So when we look at this though, a negative and a negative is going to make that positive. So that's actually going to be 29 minus 3i. Now, if you were to work out 33, you would get negative 22 plus 14i. And that is our imaginary numbers.